Welcome to Algebra 2. This video is, I guess, a review of exponent rules, the quiz on the 29th. But yeah, so let's start. What are the rules for the exponents? Um, in order for me to explain that, let's say figure out whatever terms are that we're going to use for this video. Any exponent can be, any exponential function can be written as y equals a the power of x or something, or let's just say an example of that would be 2 cubed equals 8. That's true, right? Here 2 is your base, 3 is your exponent, and 8 is your answer. I just care about the terms that I'm using in the video. So whenever I say a base, it's something to the power. If I say exponent or power, I could use power as well. Power, it's this 3 right there. Let's say power, right? PAP, power. All right, let's start. So the very first rule is the rule number one. Let's say that if you're given a term, let's say number, the base is the same. Here, x is the same, and you're multiplying two exponents whose base is the same, but the exponent is different. It doesn't have to be different; it could be same as well. The power could be same, but let's say they're not the same. Uh, the rule applies either way. As long as the bases are the same and you're multiplying it, if you simplify it, all you do is add the exponents. So an example of that would be, let's say you're given 2 cubed times 2 to the power of 4. Um, Here, what you could do is add the exponents. So this is basically 2 to the power of 7. Or if you're given x to the power of 4 times x to the power of 3, that's basically x to the power of 7. But you cannot do this if one of them is, let's say, x to the power of 5 and y to the power of 3. You cannot say that this is x to the power of 5 plus 3 because the bases are not the same. Alrighty, rule number 2. Let's start rule number 1. For all the exponent rules that we're going to use, in our case, let's start this. Rule number 2. If the base, again, if they are the same, exponent is there, power is given, but instead of multiplying, you're dividing. Guess what you would do? Instead of adding, you would be subtracting. So that would look like x a minus b, the power of a minus b. For example, let's say you're given 2 to the power of 4 all over 2 to the power of 3. Basically, you just subtract 4 minus 3 and you get 2 to the power of 1. Right? Let's say you're given x to the power of 5 over x to the power of 3. It's basically x to the power of 2 because you subtract 5 minus 3 and you get 2. All right, rule number 3. Rule number 3 basically says this: if you are given, let's just say one base, but it's double power, if there were two powers, like separated by parentheses, what you will do is you simply multiply the numbers. You simply multiply them. So example would be, let's say you're given 2 to the power of 2, the power of 3. So there are two powers. You simply make it 2 to the power of 6 because 2 times 3. This 2 times this 3 is 6. Another example would be x to the power of 4. The power of 3 becomes x to the power of 12. Cool. We'll do rule number 4. Rule number 4 simply says this. See, so far what we've been working on, bases were the same. What if the exponents are the same, but the bases are different? The exponents are the same, I said. Let's say a to the power of x times b to the power of x, where the a and b, the bases are different, but the powers are the same. Well, we can combine into one parenthesis where they share the power. So an example of that would be, let's say you're doing 2 times 3 to the 2 squared times 3 squared, right? So you can do simply combine them, 2 times 3 to the power of 2, which is a 6 squared. Another example would be, let's say x times x cubed times y cubed, combine and into 1, x times y cubed. That's rule number 4. It's this. Rule number 5, quite simple. Anything raised to the power of 0 is 1, except as long as the base is not 0. So x to the power of 1 equals 0. As long as x does not equal 0, so you cannot say 0 to the power of 0 equals 1. Some people, there's a huge debate about this, but this will not be on the quiz. But let's say you're given 3 to the power of 0, then it just becomes 1. Or 99 to the power of 0, it's just 1. Anything to the power of 0 except for 0 is 1. Rule number 6. Okay, negative power. What if you have negative power? What does happen then? Well, this is the biggest mistake I've seen among students as well while walking around was that what they would do was like they would flip the A. They would say this. Actually, I meant what it is first. Let me talk about what it is first. X to the power of negative A is simply 1 over x to the positive A. What I've seen people doing is that x to the power of negative A is x to the power of 1 over A, which is not true. This is not true at all. Not true. Okay, you have to take the base to the denominator and make it positive. An example of that, let's say you're given 2 to the power of negative 3. What is our base here? 2. Take it to the denominator and make the power 3 positive. And the example that you're given y to the power of negative 5, you will take the y and make it positive. What if you're given y to the power of negative 5 halves? You will still take the y to the denominator, just make it positive. Don't flip the exponents. Okay? And then the final rule number 7. Rule number 7 is if you're given a denominator, let's just say a is your denominator in the power, you just make it a root of a. So meaning if 4 to the power of 1 half was a question, this 2 is square root, represents square root of 4, which is 2. Let's say if you were given 8 to the power of 1/3, this becomes cube root of 8, which is 2 in our case. Okay, cool. You're given this now. These are all the rules. Let's do the circuit. I'm going to walk you through the circuit and just talk about it with all the rules that are being applied here, okay? If there is no exponent, assume it's 1, right? X to the power of 1 times x to the power of 1/2. You're going to apply rule number 1. You're going to simply add them. And you get x to the power of 3/2. That is your answer. It's simply asking you to keep it positive, right? Now, this is negative. So you're going to make it a fraction and change the exponents. Make it positive. Here, rule number, what was it? 3 that applies here. You're given parentheses. You times them. You get 4, x to the power of 4, because 2 times 6 is 12. 12 over 3 is 4. You're going to subtract here. You get 2/3 minus 1/3, which is 1/3. Question number 5. You're subtracting, so you get 1 minus 1/4, which is 3/4. Here you're going to add. You get whatever you get, just 1/5 plus 2/3, and whatever you get, that's your answer. Question number 7, you're multiplying them, so you get 5/3. Because 2 cancels out, you times them. 2 times 5 is 10. 10 over 6 is 5/3. You're going to subtract here. 1/2 minus 1 is actually negative 1/2, but they're asking you to keep it positive. So you're going to have to bring it down and keep it positive. So it's 1 over x to the power of 1/2. Due to this one, it's going to add 2/3 plus 3/4. You can add them and figure it out. Same thing here. You're going to see they're on the same side, so you're going to add them. Negative 2/3 plus 5/3 is 1 over x, 3 over 3. It is 1 over x. Clear. Let's do the harder one now. Now here's the thing. The biggest thing about complex stuff where you have multiple variables, just take them separately. What if you're given x to the power of 4 to the power of negative 1/4? You would times it and you would get x to the power of negative 1. Here you would, so you simply just distribute the 1/4, negative 1/4, and you get y to the power of -2, but they want you to keep it positive, so you're gonna bring it down. You get 1 over x times y squared, and that is your answer. Here you're given x to the power of 1. Just play with this one for a second, right? Just solve, forget the y exists for now. How would you solve this? You would simply subtract, and you get x to the power of 3/4 minus 1. And then now you bring the y, you get 2 minus 1/2. You see, all you're doing is parting one by one and solving them. You get x to the power of 1/4, which is negative in our case, negative 1/4, because 1 is greater. Here, y becomes 1, no, what is it? 4 halves or 3 halves. Cool. Positive 3 halves, right? But this is negative. They want to keep it positive. So it's y to the power of 3 halves over x to the power of 1/4. Then negative brings the x down and keeps it positive. Now we do the same thing here. You get -6 to the power of 5. It's y to the power of 5, x to the power of 6, and that's your answer. Do the same thing here, but you're going to subtract 4/3 minus 1, 7/6 minus 1. So this is what? I need a 3, so it's 1/3. This, I need a 6, so this is 1. 6 minus 1/6, right? You can figure it out. If I'm not right, just I think it's right. Let me see. The power of 1, I'm going to put. Perfect. Here you're going to subtract, you get x to the power of 3/4 minus 1/4, y to the power of -2/5 minus 1/10. So this is 2/4. Y is negative, so wait, I need a 2, so -4/10 minus 1 is -5/10. And if you were to rewrite this is x to the power of 1/2, y to the power of -1/2, you get x to the power of 1/2 over y to the power of 1/2. And that is your answer. I simply just simplify after that, right? We all can do that. Now, 1/3 is basically cube root, and cube root of 216 is 6. Now, you're going to take this cube root to this as well, and all three of them, right? This gets -2, y is 1, so it's 6y over x squared, and that is your answer. Now, same thing here. You get 125 to the power of -2/3, x to the power of positive 4 now, y to the power of -6. So this is x to the power of 4. Now 125, cube root of 125 is 5, and 5 squared is 25. And then y to the power of 6. So that is your answer. X to the power of 4 over 25, y to the power of 6. I meant 10. Okay, why is it 10? No, it should be 6. Oh no, 10. I meant 10. 3 times 5 is 15 over 3 is 5. 5 times 3 is 10. I don't know why it's 6. Okay. Don't make this mistake, calculating mistake, okay? Don't make that mistake. Like I did. So it's 16 3/4 x to the power of -1/2, y to the power of 6. Yep. Now you get 16, 4th root of 16 is 2, 2. Okay, why am I saying 4th root? The 4 is in the denominator, right? So it becomes 4th root of 16 cubed over x 1/2, y to the power of 6 remains up there. So 4th root of 16 is 2, 2 cubed is 8, so it's 8y over 6, x to the power of 1/2. Is that an option? Yep, right there. Now this one, square root of 81 is, so you're going to distribute this 81 everywhere. I mean this 1/2 everywhere. So you get 9 x to the power of 3, 12 y to the power of 6. Simplify this, 9 over 12 is shared by 3, it's 3 over 4, x cubed, y to the power of 6. With this one, you're going to distribute cube everywhere. 2 cubed is 8, x3 to the power of 3 is x to the power of 9, y to the power of 9/5, x to the power of 5, y to the power of 2, and then simplify it, you get 8x to the power of 4, y to the power of 9 fifths minus 2, which is y to the power of negative 1 fifth, is 8x4 over y to the power of 1 fifth. Is that an option? Yep. Now, this one, I'm going to tackle this. We get it together, okay? Distribute the square, you get 9x 3 fourths, y 4 fifths, 25 x to the power of 1 eighth, y to the power of negative 3 fifths, times 81 to the power of 1 third, x to the power of 1 half, y over 8 to the power of 1 third, times x to the power of 3 halves. I simply distributed 1 third amongst each term in the power and times it together. 9 over 25, I'm going to leave it as it is. X to the power of 3 fourths minus 1 eighth, y to the power of 4 fifths plus 3 fifths. 81, cube root of 81, I don't know, it's not a perfect number. And then x to the power of 1 half minus 3 halves, and y to the power of 1. Wow. Okay. 9 over 25, of course, all over 8, 1 over 2, because 8 cube root of 8 is that. This is 3 fourths minus 1 eighth, which is 6 eighths minus 1 eighth, which is 5 eighths. And then on the other side, we have, so it's x to the power of 5 eighths minus, what is this? Can you imagine now? Okay. Negative 2 over 2, so it's 1. 5 is minus 1. Y to the power of 7 fifths minus 1. Of course, the cube root of 81 over 2 is still there. And you can just do that. So you get cube root of 81 over 2. Okay. 5 minus 1 is 8 over 8. So negative 3 eighths. You get 9 over 25 times cube root of 81 over 2 times, this is in the denominator, 1 over x becomes positive, 3 over 8 times 7 fifths, so 5 over 5, x y to the power of 2 fifths. But as you can see here, this is the most simplified version that I can think of. X and y, there's only one x and y and stuff like that. But this is not something that's going to be in the quiz this complex. I made some of the questions of my own that I think would be very helpful for us to look at. That's going to be your review for the quiz as well. How, if they're asking you to rewrite this using radicals, radicals basically means this, right? That's a radical by definition, okay? So here, for to write this, what is in the denominator? It's 11, and that goes on the outside. And the 6 stays with there. Now, you could also rewrite this as root 11 x to the power of 6 on the outside. These two are the same thing. So if you have this and it's select all, you select both of them. Okay, we're just using radicals. First, I would have to keep it positive, so bring it in the fraction. 1 over k to the power of 1 ninth equals 1 over root k, where the root is, the 9 is outside, and that becomes my answer. Okay. All right, next one, we're using radicals. Again, same thing. Square root 81 cube, square root 81 to the cube outside. We can simplify this. Square root of 81 is 9. 9 cube is whatever it is. You can figure it out. Now, this one, you're going to have something like this on the quiz. The first thing I would do is just break it down. 27 over 3. Break that first. Is 9. X to the 4 over x to the power of 2. You can subtract the exponents, you get x to the power of 2. This can be rewritten as y to the power of 3 halves and y to the power of 1 half. Now we're going to subtract the exponents, so you get y to the power of 3 halves minus 1 half. So 9x squared equals y to the power of 2 over 2, which is just 1. So that is your answer. 9x squared y. You see, how do I know that's my answer? There's only one number, one x, and one y. exponent is positive, there is no fraction and stuff like that, so that's the most simplified version. Rewrite this. Fourth root of 6, so you're gonna have to share the fourth root with everyone by dividing it, right? So since it's the radical, you take it to the denominator. That's the rule. 16, fourth root of 16 is 2. 12 divided by 4 is 3. 5/4 is already is done, so this is the more simplified version. Alright, that's it. Yeah, that's it. Cool. Yeah. If you have any questions, that's what can I do now? Try your best.